So today we are starting chapter 3. We're starting chapter 3 today. Now, what we're mainly going to be covering in chapter 3 is a lot dealing with parallel and perpendicular lines. Parallel and perpendicular lines. Now, the first thing we're starting off with for this note sheet is this core concept, talking about parallel lines, skew lines, and parallel planes. Now, I had y'all go on and find the definitions of these yesterday. Well, not yesterday, Monday, when you did the vocab sheet. Well, we know parallel lines are two lines that what? Do not intersect. But we have to specifically state that they are also coplanar. They lie in the same plane. They lie in the same plane for them to be considered parallel. Now, if they do not intersect and are not in the same plane, we would call them what? Skew lines. Because skew lines, when they do not intersect and are not coplanar. Also, we can call two planes that are parallel to each other parallel planes. So really, parallel lines are two lines that are contained in the same plane and never intersect. Now, the real definition, if we get down to it, the proof, or not proof, but the kind of definition of parallel lines in Euclidean geometry is going to be a point. If we have a point and a line that does not pass through that point, there exists exactly one line through the point that is parallel to the given line. So given a line and a point, there's exactly one line through that point that is parallel to the given line. Well, how many lines can we have that are not parallel to it? I mean, tons, because I can draw any other line through that point that either is going to intersect it at some point, yes? Because there's only going to be one line that's going to go through this point that is exactly parallel to it. There's lots of others that are not. Now, what we'll be mainly doing today is identifying lines, segments, planes that classify or follow the information that's given. Think of each segment in the figure as a pair of, or as a part of a line, which lines or planes appear to fit the description. So we're just naming the line or plane that fits the description that they want. So A, line or lines parallel to CD and containing point A. So we have the line CD, and we want a line parallel to it that contains point A. So what would that be? So what line, or because we can consider them all line segments, what would it be? AB, yeah, because line AB is in the same plane as CD, because through any 3 points we can create a plane that extends indefinitely. So we're just finding the line that's parallel to it. They are parallel to each other, yes? And we know that because of the right angles, we can say that those are parallel. Would EF be parallel to CD? Would line EF be parallel to line CD? EF. As long as those are right angles and this is a cube, we could say yes that they are parallel. Would we had include it for part A? Does it satisfy the question? Line or lines parallel to CD and containing point A? Well, does EF contain point A? No. It is parallel to it because, again, we can have two planes Because EF is contained in the plane with CD, but it's going vertically. And BC and AB's plane is more horizontal. But that would work if it wasn't asking us for the line to contain point A. If it just asked for a parallel line, that would work. Okay, how about lines skewed to CD that contain point A? Well, I know I'm going to need A. AH and A. Not that slide. Skew lines. Skew lines are skew lines when they do not intersect and are not coplanar. So AG is not coplanar because point G is not contained within the plane. So by our line plane postulate from last chapter, if 2 points are contained within the plane, then the line containing those 2 points is contained within the plane. Well, G, for AG, G is not contained within the plane. So the line AG would not be contained within the plane. So that works. And AG does not intersect CD. So that's it. AH. Well, H is not contained within the plane. So line AH is not contained within the plane. And it does not intersect line CD. Questions on this here? C. Line or lines perpendicular to line CD and containing point A. Hey, what? It's not going to be AB or AG. So perpendicular means that they do what? They at a certain type of angle. Right angle. So it would be AD. Because we need a line segment through, or a line through A that intersects CD at a right angle. Well, that would be AD. And that's it. Any questions on any of this so far? Planes parallel to plane EFG and containing point A. Almost. I would agree with AB, so plane. Because ABC, because EF, let's see here, sorry, EFG. Yep, nope, you're right, ABC. For some reason, I had it in my head that it was EFC, that we were actually looking at this plane here. Not the one straight down. No, you had it right. Well, we could name it, because ABC, we could say ADC, ABD. Any of those 3 letters would work. Questions on this here? Look at the diagram in example 1. So what we have right here. Name the lines through point F that appear to be skew to EH. So EH and through point F. So we would have F, FC or CF, yes. Are there any others? Yeah. Because do we have any other lines connecting to point F that aren't contained within the plane? Because the other lines that we do have, FE and FG, are both contained within the plane that contains line EH. Because skew has two main properties. They do not intersect and they're not contained within the plane. Because E, F, and FG are both in the same plane as our given line, they would not work. Because FG doesn't intersect, and as long as they're all right angles, we're talking about a cube, those would be considered parallel since they're in the same plane. FE, as long as that's a right angle, they would be considered perpendicular because they do intersect. Any questions on this here? So lines that are parallel to GH and containing point F. Yes. FE would be a line that is contained within the plane and is parallel to our given line. Because there's no other line that would be parallel to it because the others do intersect. Well, I can just leave that there because it looks like we're going to be completely revolving around line GH. FB or BF, because again, BF and GH do not intersect. And point B is not contained within the plane of GH, so it would be considered skew. Lines perpendicular to GH and containing the point F. Because this is the only line that is intersecting HG. And we are assuming that they are all right angles. Planes parallel to plane GHD. So GHD, and we want point, so plane BAE. I'd say BAF, since they want point F. I mean, BAE would actually work because BAE is the plane that does contain point F. Well, it would work because it does contain it, technically. And especially on this assignment, I'll be making sure to look and see, does it actually contain it? Because if you said BAD, well, that wouldn't quite work, or any of the others. Any questions on this here? Are you good with this here so far? Identifying parallel lines and perpendicular lines. Two distinct lines in the same plane are either parallel, like L and line N, or intersect in a point, like lines J and line N. Through a point not on the line, there are infinitely many lines. There's infinitely many lines we can draw. Exactly one of these lines is parallel to the given line, and exactly one of these lines is perpendicular. Okay, that's fine. I mean, it's not too big of a deal. It's also contained in your book. For example, line K is the line through point P perpendicular to line L, and line N is the line through point P that is parallel. So our parallel postulate and our perpendicular postulate, because this is right there. If there's a line and a point not on the line, then there's exactly one line through the point parallel to the given line. There's going to be exactly one. Perpendicular postulate. If there's a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. So for any line and a point, we can only have one line that's parallel and one line that is perpendicular. We only have one. Parallel, we'll normally give these little arrows on them to show that they are parallel. This here signifies that two lines are parallel. And one thing that we can do is if we have multiple lines in a figure that are parallel, but they're not all parallel to each other, we can signify that with multiple, because we can add a second one for other lines that are parallel to each other. So we can have this just like with our congruent segments or congruent angles using the angle marker or hashes. We can do the same thing. Now with lines being perpendicular, we use our right angle marker, because two lines are perpendicular if they intersect at right angles. So what we'll be doing on this here is we want to name a pair of parallel lines in the figure. So DE and CE and BF, possibly. But the only issue that I have with that is that we aren't really told if those are parallel to each other. EF for sure, with DM or DA or MA would be parallel. Because of these little arrows here, it says that they are parallel to each other. Name a pair of perpendicular lines. Yes, and AB wouldn't, MA wouldn't be a line because we'd be talking here to M, because we're talking about this line segment here and this line segment here. Because of that right angle marker between those two where they intersect, that would work. Now, AC or AM, since it's intersecting at that weird spot, it doesn't quite work. But also, since that angle marker is showing that those two lines are perpendicular, because given a point in a line, how many lines can be perpendicular? One. So since those two are already said to be perpendicular, CM or MA cannot be, because there can only be one line that is perpendicular to a given line and a point not on the line. Is FE parallel to AC? Why not? Well, they are. Well, we're considering this whole thing to be the plane. Because what is parallel to EF? DM, yes? Well, so through a point, so point M is contained on the line, yes? And it's also contained in line CA. So our parallel postulate states, given a line and a point not on the line, there's exactly one line through the point that is parallel to the given line, yes? Well, EF through that point M is parallel to DM, yes? So can any other line through point M be parallel to EF? Well, no, it would also have to be the line DM. So it can't be because it's not a part of that line. Does that make sense? Well, you can also see that it's going to eventually intersect it, but so this would be no. And last but not least, can you use the perpendicular postulate to show that AC is not perpendicular to BF? AC is not perpendicular to BF. Well, we can talk through this. I'm not going to make you write this whole thing out, because through line BF and point M, there's exactly one line through it that are BF and D. There's exactly one line that's going to be perpendicular to it. And we know that DM is perpendicular to BF. So AC cannot be perpendicular to it. We already have one line that is perpendicular to the given line, and AC is not it. Does that make sense? So our parallel lines for this here, so we're looking for our parallel line markers, which we have here, which would be HL, GK, GM. We could use either one of those. Or not GM, GK would be the only one. M is located down here. I thought it was on the other line. And KG, or GK, because these two here are perpendicular, and we know it because of the right angle. A little much. Is GN perpendicular to JL? No, there's no right angle marker, and we already have one. So no. Any questions on any of this here? Any questions on anything we've done so far? Identify pairs of angles. Identifying pairs of angles. A transversal is a line that intersects two or more coplanar lines at different points. So if we have two lines and a line that intersects both of them, this would be considered a transversal. Angles formed by a transversal. Now we do have all of this here. Now the first one we have is corresponding angles. They lie on the same side of the line and on the same side of the transversal. So when we look at the two given, 2 and 6, well, they both lie above the line and to the right of the transversal. So they are corresponding to each other. They correspond. I can really say they are in the Same spot, same location. Alternate interior angles. Well, alternate means what? Opposite, because we alternate, we're flipping something. And interior means inside, because alternate interior means that they are on opposite sides, they're opposite and inside. Alternate interior angles are opposite sides of the transversal in between the two lines. So when we talk about alternate interior angles, well, alternate means opposite, and they are between the lines. Opposite sides of the transversal and inside the two lines. Any questions so far about corresponding angles or alternate interior? Well, the next one we have 1 and 8. Well, that would be alternate exterior angles. Well, they are on opposite sides of the transversal. And outside the two lines. Because alternate interior, they were on opposite sides of the transversal, and between. Alternate exterior, they're on opposite sides and outside the transversal. And the last one is consecutive interior. That's trash. Well, consecutive interior angles, same side of the transversal and inside the two lines. Consecutive interior on the same side of the transversal and between the two lines. Identify all the pairs of the given angles. So corresponding, so angle 2, and so angle 2 is above the transversal and to the left or to the right of the line, yes? So if I look at the other line, which angle is above the transversal and to the right? So 2 and 6, because they're essentially in the same location. Now corresponding is just kind of the same location. So 1 and 5, 3 and so it goes 7, and then angle 4 and 8, because 3 is below and to the left. 7 is below and to the left. They're in the same location. They correspond to each other. Now corresponding angles with two lines and a transversal will deal with 4, because each line will have 4 angles. Now alternate interior angles. Opposite sides of the transversal and are inside the two lines. So we're looking at 2, 4, 5, and 7, because there's the 4 that are contained between the two lines. So 2 and 7, because they are inside the two lines and on opposite sides of the transversal. The line that's cutting between them. So 2 and 7, then we will also have what? 5 and 4. Those are between the two lines and on opposite sides of the transversal. So they're alternate interior. Alternate exterior. Exterior would be which 4? 1, 3, 6, and 8. So we'd say angle 1 and 8. Yes. 6 and 3. Outside and opposite the transversal. Outside and opposite. Consecutive interior. Well, consecutive is really meaning next to each other, yes? Interior is inside. So we're looking at 2, 5, 4, and 7. 2 and 5, because 2 and 5 are consecutive. They're next to each other. Now we can have something, they don't really talk about it too much, but consecutive exterior. So 1 and 6, 3 and 8 are consecutive exterior, but we really don't talk about those. Questions on this here? So consecutive interior angles. So 7 and 8. Eight and 7. Because again, because consecutive interior angles, we're talking about the two angles that do follow this. 8 and 7. Because the other set would be, so we could say 4 and 3. Because as long as you're putting the two angles together. It would be incorrect if you said 7 and 4, because those are not consecutive interior. Alternate exterior. 1 and 5. 2 and 6. Now, what would our corresponding angles be? 8 and 6, 3 and 5. 1 and 7, yes. And last but not least, alternate interior. 8 and 4, and exactly 7 and 3. Right, because corresponding means they're corresponding to each other. They're matching up. So 1 is above the transversal and to the left. So I'm looking at the other set of 4 over here and seeing which one's above the transversal and to the left, and that would be 7. So we're seeing which ones match up. Now, answered your question? Now, with corresponding alternate interior, alternate exterior, or consecutive interior angles, are we ever talking about any of the angles that are next to each other or on the same piece together? Are 1, 2, 3, and 8 ever talked about together for any of these here? Well, no. Because again, when we relate them, we're relating the two sets. With these 4 here and these 4 here together. Any other questions on this here? Yeah. First one would be corresponding. I think I forgot an N. Exterior, because again, corresponding, they're on the same side of the line and on the same side of the transversal. The number 4 is alternate exterior because they're on alternate sides of the transversal and outside the two lines. They're alternate and they are on the exterior. And exactly number 5, well, 4 and 5 are on opposite sides of the transversal. So it would be alternate interior, because they're on opposite sides of the transversal and in between the two lines. Now, we will get special properties that come along with these if the two lines are parallel. Then we can actually get a lot of information from it. But at this point here, we can't say much if we don't know the two lines are parallel. And that is it. Okay, so y'all's homework assignment, which has already been posted to Google Classroom. There's the background report. I just don't have it typed up here. Is on page 117. Problems 3 through 18, comma 20. 3 through 18 and 20.